All right, hello again, Algebra 2 people. So today we're going to be talking about writing absolute value equations and solving absolute value equations from the dreaded word problem. Now the good news about these word problems is they're always going to be in the same format. There's not going to be any tricks to them. It uses something, so absolute value functions are useful in real life. With something called tolerance. If any of you are interested in going into like manufacturing of just about anything, like car parts or like little ball bearings that go in skateboard wheels, things that go out in space like telescopes, whatever. All of these things have to be made into a certain tolerance, into a certain size. Which then, and what tolerance means is there's an ideal size that we want it to be made in or made as, and it can vary by a little tiny amount, but if it varies by too much, then it's not going to be useful. Okay, so that's what we call tolerance. So all of these problems are going to be the exact same way. So you're going to be reading the problem and looking for what is it, what size do we want this thing to be, and how much can it vary by, okay? And the way the equations are going to be set up is always going to be like this, where it's going to be the absolute value of x minus what you want, what I call a target, and we're going to set that equal to the tolerance, how much it can vary by. Different words you're going to see for tolerance. You might see the word tolerance, you might see variance, you might see like plus minus, different or within, something like that. So, but it's always going to be that same number. Okay, so let's go and jump into the examples here and see what these look like. So first question, the recommended weight of a soccer ball is 430 grams. Actual weight is allowed to vary by up to 20 grams, right? And solve an absolute value equation to find the minimum and maximum acceptable soccer ball weights. So again, what do we have? So we know we want the soccer ball to weigh 430 grams, so that's our target, and it's allowed to vary by 20 grams. So that means my equation is going to look like the absolute value of x minus 430 is going to be equal to 20. That's your equation. That's all. And that's the same format is going to happen every single time. Now to solve this, to actually find the minimum and maximum acceptable weights, you just solve what you have. And if you remember from the previous couple of days, the absolute value is already isolated. So all we got to do is set up our two equations. So x minus 430 equals 20 and x minus 430 equals negative 20. And of course we add 430 to both sides on each equation. So we have x equals 450. Do the same thing here. We have x equals 410. So that's our minimum value, and that is our maximum value. Anything in between there, and it's okay, and we can use that. Part B is just kind of an application of that same question. So now you have a ball that weighs 423, and obviously that's okay because that's within our tolerance, our variance. Due to wear and tear, the weight of the soccer ball decreases by 16 grams. Is the weight acceptable? So if it starts at 423 and we subtract 16, well, that becomes 407. And notice that is outside, that's less than the minimum weight. So that would be a no. They would have to either throw that ball away or do something with it to bring it back up to spec. Okay. The rest of these things work exactly the same way. So I'll go and do the next example. Then I got two more down below, and I'll let you work on those by yourself, and then we'll zip through those answers. So example 2, ball bearing must be 1.54 centimeters in diameter with a tolerance of 0.05. So my target is 1.54, so 1 minus 1.54, tolerance of 0.05. There's your equation. That's all there is to it. You want the minimum minimum, maximum, you just solve it. Then we add the 1.54. So we have x equals 1.59. And x equals 1.43. And again, this is your minimum value and your maximum value. Anything in between there is going to be okay. Last two examples. So, this is actually example 3 and 4, even though I'm a math teacher. Sometimes I have a hard time counting to 4. So example number 3, I'm going to let you guys do these two on your own. If you want to pause the video, if you haven't done these yet, if you weren't in class that day. But go ahead and work on these. The one thing about example 3, notice the units need some work. So we have a 2-pound packages, but the variance, our target, is 0.3 ounces. So you probably want to put the pounds into ounces and then go from there. So go ahead and pause the video, work on that one and example 4, and then we'll zip through those real quick. Okay, so for example 3, notice there are 16 ounces in a pound. So 2 pounds is actually equal to 32 ounces. Right, so our equation becomes the same thing. So absolute value, my target is 32. And my tolerance is 0.3. And you just solve it. Add your 32. And you get minimum value, maximum value. The one nice thing about the tolerance questions, again, they're always in the same format. Last question, and this is another way you can see it written. Again, the 1.8, that's what I want. And the 0.25, don't really worry about the plus or minus, because we're going to do that when you solve the equation, but that 0.25 is your tolerance, your variance. So again, write the equation, always the same format. And then we can solve. So add the 1.8. X equals 2.05. And x equals 1.55. You get minimum and maximum. So that is all there is to doing word problems with absolute value, finding minimum, maximum values. Obviously, anywhere in between those, we could actually do these as inequalities, but usually they're written as absolute value equations just to find that minimum, maximum value. But keep in mind, anywhere in between those values is also okay. Okay, so if you need some help, come into tutoring. Next time we'll be doing some absolute value inequalities. Until next time, stay safe.